We have some definitions. I went over these, I believe, already, but I'm going to go over them again. Okay, so to measure is to ascertain the dimensions, quantity, or capacity of an object. You guys know what measuring is. You don't have to write this down if you don't want to. Okay, I do want you to write down angle, though. An angle is formed by two rays that share a common vertex that's called they share a common endpoint, and it's called the vertex. So if you have this ray and that ray, here's the vertex. Okay, and just as a reminder, a ray is a straight line extending from a point. If you already know that, you don't need to write it down. Yeah. And then the vertex is the point at which the sides of an angle intersect. So it's here, vertex. Okay, and angles are made of rays, so even though we draw an angle like maybe small, this goes on forever like that, and then forever like that. Okay, a semicircular instrument for measuring and constructing angles is a protractor. Yes. Now, a protractor, an acute angle, is an angle less than 90 degrees. And a way I remember it is it's little, so it's cute. It's a cute angle. It's little, right? Okay, a right angle is exactly 90 degrees. So exactly 90 degrees. And then we have obtuse angle. And they're big. They're more than 90 degrees. And so they're kind of fat. And obtuse is sort of like obese. So you've got a acute angle, which is little, a right angle, which is perfectly 90 degrees, and then an obtuse angle, which is big. So the protractor postulate states that the rays in a semicircle, which is a half rotation, can be numbered from 0 to 180 so that positive number differences measure angles. We cannot have a negative angle measurement. There's no such thing as negative angle. It's always positive. So what you do is if you look, going this way, we go from 0 to 180 on the top, and going this way, we go from 0 to 180 on the bottom. The vertex always aligns here. Now, you don't have to draw this if you don't want to. I'm just, So, but if you look at any protractor, there's going to be a dot or a crosshair in the center of the bottom is where you stick for the vertex. Now, if the angle comes, opens this way, you're going to measure on the outside. So you'd measure from 0 to, well, this isn't lined up, so this one probably like a 40-degree angle maybe. If the angle opens up this way, you're going to measure this side. So you always line the vertex here, and then you're going to line a ray either here or here. I know I'm not drawing straight lines, but in perfect alignment to this line here. So you line up the ray along this line with the vertex here, and then if it opens this way, you're using the 0 to 180 on the bottom, and then if it opens this way, you're using 0 to 180 on the top. Yeah.
Why is the one over there going by 5 and that one's not? You see it got like a half.
Here? Oh, well, because it's 10 and 170 are the same space. Like this line would continue through here.
Yeah.
So that would also continue through. So that would also be like a 5. Does that? Okay, yeah. There's just not enough room in the printing to make it look good. Now, if you look at my actual protractor, I don't know if you guys can see this. Hold on one second. Classify them. Okay, so what we have is this is angle ABC with the word, or you can use just the symbol of an angle and write angle ABC. From now on, if you want to write the word angle or use the word angle, you can just draw an angle. You don't have to actually spell out the word angle anymore in this class.
Nice.
Okay? So this is angle ABC. This is ray BA, and the B has to go first because the B is the vertex. Or you can use the symbols, a BA with a single arrow over top. And the B is the vertex, so it has to go first. And then this is ray BC. Point B is your vertex. All right? Now, bless you. Our green angle here, this little square, that's what tells us that this is a right angle. If it does not have that little square, unless you've measured it, you can't say it's a right angle because it could be 89.5 degrees or 89.8 degrees or something. And it could look like a right angle, but it maybe is not. So it has to have this little square here for you to know it's a right angle without measuring it. Okay, if it's smaller, it's cute. So it's an acute angle. And if it's bigger, it's obtuse. To use the protractor, you line the vertex into the little dot in the center. There's a hole. Sometimes there's not an actual hole. Sometimes it's just a circle printed on the plastic. But you line up the vertex in that hole or circle. You have to line up the ray along this line. So if the angle is going this direction, opening up this way, you'd line this bottom ray up over here. And then you figure out which way, where this is pointing to. If you have an angle and it comes like this and it goes like that, and it's hard to tell where is that lining up to, right? You're going to take a ruler or the edge of your protractor and draw the line longer. So we would extend the line out, and then you know where it goes. Okay. And then you read the number that's written at the point of the intersection up here. So which number is this? 60 or 120?
60.
It's going to be 60 because we started at 0 and we went this way, so it's 60. It would only be 120 if we had started at 0 and came out to here. So you count from 0 and then you go up. So whatever you're lining up at 0 on this side, so you're counting on this bottom row. If you were lining up at 0 over here, you're counting on the outside row. Does that make sense? Oh, yeah, it didn't print very well. Or copy very well. I guess it's not printed, it's copied. Okay, so again, like I was saying, if we go this way and you line up the ray this way, we're going to read on the outside numbers, and that's how you'd get the 120. Also, now that you know the difference between an acute and an obtuse angle, if you look at this angle and you say it's 120, it's smaller than 90 degrees, so you'll know, okay, no, it can't be 120 because it's smaller than 90. So that just, check yourself that way. Okay, so acute, right, or obtuse?
Acute.
Okay, and then we're going to measure it. So I'm going to take my protractor and see that hole right there? I'm going to line that hole up to my vertex. And when I come up this way, it's hitting at 45. Because my 0 starts here. And I go like that, and it hits at 45 right there. So this angle is going to be 45 degrees.
Do we need to copy this?
No, you don't need to copy this. This is just...
We're just going to measure the...
Okay, I'll get you one. We have vertical angles. Okay, so vertical angles are a pair of angles that share the same vertex, but they're bounded by the same set of lines. So it's not like two angles that are next to each other. It's two angles that are across from each other. So if I draw two lines that are going in an X, here's the vertex. This angle and this angle are vertical angles. That's one pair of vertical angles, and then this angle and this angle are another pair of vertical angles. So you have, anytime you have two lines crossing, you have two pair of vertical angles. So these are vertical and those are vertical. Okay. Congruent angles are two angles that have the same measure, and the symbol for congruent again is an equal sign with like a squiggly over top of it. So any two angles that have the same measure. So if this angle is 60 degrees, that's not, but let's just say it is, and then this angle over here is 60 degrees, these two angles are congruent. Okay. Then we have complementary angles. And complementary angles add up to 90 degrees. Okay, yeah. Yes. Okay, so complementary angles add up to 90 degrees. A good way to remember this is if somebody compliments you, they are right. Complementary right angle. So if somebody compliments you, they are right. And then the other one, you get supplementary angles. And supplementary angles add up to 180. I don't really have a clever thing for this, other than complementary is 90 and then the other one's 180. Ready? Two angles that share a common ray and a common vertex are called adjacent. Make sure I spelled that right. Okay, yeah, I did. Adjacent angles. Okay, so adjacent angles look like this. They share a common ray and a common vertex. So this angle and this angle are adjacent to each other. So A is adjacent to B. So they're attached. So you can say next to each other, attached.
So, if it's adjacent, then it's just the middle that makes it that way?
Yeah, this is one angle, this is another angle, and they share a wall. Yeah, they share a wall, like a ray. They share a wall. So like this is one apartment, that's another. This is the wall between them or something. Yeah. Okay. Two supplementary adjacent angles formed by two intersecting lines make a linear pair. Okay, so.
What the heck? Okay,
All right, a linear pair. Just any two angles that add up to 180 that are adjacent are a linear pair. So they make a straight line. Okay. So they add up to 180.
And they share the middle or something?
Yeah. So A and B equal 180. It's a linear pair. They make a straight line. Straight line is 180 degrees. So if you have a straight line and two angles, so what they're talking about when they say intersecting lines, this ray here would continue out like that. And you'd have B and A make a linear pair, C and B make a linear pair, C and D make a linear pair, and D and A make a linear pair. Do you guys see that? So any two of the ones that make up a straight line.
Adjacent angle that is.
Yeah, it's adjacent angles that make a straight line. Okay, so you can write that. You can write adjacent angles. Here's how you say angles. And they make a straight line. Okay. And then finally we have an angle bisector. Okay, and an angle bisector divides the angle in half. So if I have some angle here, if I cut it in half to where this measure and this measure are the same, So if this is 30 degrees and this would be also 30 degrees, this would be the angle bisector. So
So
I'll make that.
angle bisector is just a line between two equal things.
Yeah, it's the, I can't trace that line now. Okay, hold on. Let me read you all that so I can make it prettier.
Yeah, because it's bisected both of them.
So I have an angle,
My line's 2.
and I have another ray that comes and cuts that angle in half. And as long as these two are the same measure, so I'm just going to write A and B. So as long as A equals B, the blue line is an angle bisector. Bisect means to cut in half, and anytime you cut something in half, perfectly in half, they're the same size.
I don't like that.
Okay, so the angle addition postulate, I want you to know when you're talking about angles, whatever letter you put in the center is the vertex. So the vertex has to go in the center. This could be CBA or ABC, it doesn't matter, as long as B is in the center. Yeah.
What did you say?
For angle addition, isn't it like little angle plus little angle
Equals the big angle, yeah. So if you have D is on the inside, so we have an angle A, B, C. So this is A, this is B, this is C. And I make D here. Okay. If I draw a line to, or a ray to go to D, then the measure of angle ABD plus the measure of angle DBC is equal to the big angle ABC. So I'm gonna also label these with numbers because sometimes that helps.
I don't like ABC.
You do need to learn that though, because you need to know how to name an angle. Okay, so the center is always the vertex. So this would be ABD, which is also angle 1.
That's what angle.
So the angle of measure 1, or the measure, sorry, the measure of angle 1, and then DBC is this angle, so I'll call that angle 2, plus the measure of angle 2, and then the whole angle, I'm going to call angle 3, is equal to the measure of angle 3. Now this little m in front says the measure of the angle. If you don't put the m in front, you can't, like I can't say angle ABD equals 50. I have to say the measure of angle, put the little m in front. Because just if I just say angle ABD, I'm just naming it. If I put the m in front of it, I'm talking about how big it is. Okay? So basically all this is saying is the two little angles that are attached to each other make up the same total as the big angle. So if this is 40 and this is 30, this would be 70.
Okay, so
Does that make sense? Okay, the next one we have is the angle bisector postulate, which says an angle has exactly one bisector. Which makes sense, right? If I have an angle, I can only cut it in half in one spot. If I move even like a 1/10 of a degree over, it's no longer perfect. There's only one spot where you can cut it perfectly in half. So that one I think kind of makes sense. And then the linear pair postulate says that two angles that form a linear pair, linear has an I and an R, are supplementary. So they equal 180 degrees. So any two angles that form a straight line are also supplementary. So linear pair angles are also supplementary angles. And vice versa, supplementary angles will also be a linear pair if you stick them together. So if you had two angles that are floating off in space separately, if you stuck them together, they'd be a linear pair.
I feel like writing like
Okay, so our postulate tells us that two angles forming a linear pair are supplementary. The fact that they're supplementary tells us that it equals 180 degrees, and that becomes a theorem. So these two are very similar, but it's that linear pair are supplementary, and then that lets us know that they're 180 degrees. And then we have the vertical angle theorem, which tells us if two angles are vertical, the postulate tells us that linear pair is supplementary. Then that in turn tells us that the sum of the measures are 180. So this postulate creates the theorem. So the postulate is just that they're supplementary, and then the theorem is that they're 180. It's just technicalities. Yeah. Now with a vertical angles are congruent. Okay, so if I draw this picture here, I get two pairs of vertical angles. The measure of this angle and the measure of this angle are the same. The measure of this angle and the measure of this angle are the same. Okay, so vertical angles are congruent. So what I usually do, if I have room, is I'll say red equals red and blue equals blue. And if I take red and I take blue and I add them together, I get 180. Because these make linear pair, right? So red is equal to red, blue is equal to blue, and red plus blue is 180. So any red plus any blue would be 180. Okay, we're finding a complement and a supplement is just subtraction. So if I find the complement of 35, complements are 90. So I'm going to do 90 minus 35. And that equals, okay. And if I find the supplement of 35, I'm going to do 180 minus 35, which is 145. Okay. Now, this is just, yeah, you don't have to write all that. You just write complement of 55 or 35. Now, if I ask you for the complement of the supplement, no, wait, I can't do that. Not on this one. That one won't work. Sorry. If I ask you for the supplement of the complement of 35, you do this part first. So I'm going to do 90 minus 35 equals 55, right? Now I'm finding the supplement of 55 now. So I'm going to do 180 minus 55. Right, so 180 minus 50 is 130, minus 5 is 125. So the supplement of the complement of 35 would be 125. So you just do the second part first, and then whatever answer you get there is what you subtract from the other one. Does that make sense? Okay. Get a lot of these where you got these pictures, right? And you want to find x and y. Well, y, this angle and this angle are congruent, right? They're the same. So that means y is equal to 123. Now, these two angles are the same, but if you remember I said red plus blue equals 180. So to find x, I'm going to do 180 minus 123. So 180 minus 120 is 60, minus 3 is 57. Yeah, for A, I'm going to do 90 minus 56, and I'm going to get what? 34? Do you guys agree?
Yes.
Okay, what do I do for B? 180 minus 93, and I'm going to get 87. Okay, perfect. Here we go. I know that 43 and y add up to what? 43 and y make this straight line, right?
180.
Yeah, so y plus the 43 is equal to 180. So to find y, I do 180 minus 43, which is 137. And what do x and 43 add up to? 90. So why am I writing y? X plus 43 is equal to 90. So to find x, I'm going to do 90 minus 43,
47.
and I'm going to get 47. Okay, now it's sort of the same thing over here, except this one's a little more complicated. What I have is y and 36 add up to what? 90. So y is equal to 90 minus 36. So that is 54. Good?
I don't, if it wasn't degrees, it could have been like the hypotenuse theorem.
Okay. Now, 54, guys, this one is vertical to this one. So that's going to be 54. And this one is vertical to this one. So this is going to be 27. Now, I know I can add up these three and make a straight line, right? So x plus 54 plus 27 will equal to 180. So to find x, I have to do 180 minus 54 minus 27.
99.
Yeah? Okay, so x would be 99. And that's how you're going to do these assignments. So what I'd like you to do for homework